Section 14E, question number 1, page 357. We're asked to find from first principles the derivative function f prime of x, given a variety of functions. So the first one is f of x equals x. So f prime of x, the derivative function from first principles, is the limit of f of x plus h minus f of x all over x plus h minus x as h approaches 0. So recall that this is the same formula as the gradient formula. Here's the y2, this is x2, and there's y1, the coordinate of point 1, the y coordinate of point 1, and here is x1, the x coordinate of point 1. And then we just have to do a little bit of simplification. So the limit of, well, the function is x, so it's x plus h, because we're finding a point a little distance h away from that y value of x, minus x all over x plus h minus x as h approaches 0. Then we can simplify things down, so we see x and negative x cancel out. So we're finding the limit of h over h as h approaches 0. We can simplify this, so that's again the limit now of 1 as h approaches 0, which just gives us 1. So the derivative function of f of x equals x is 1. Now we move over to question 2, function 2, and the function in this case is f of x equals 5. So this is a constant, therefore we know that it's going to be a horizontal line. So f prime of x, is the limit, again, of f of x plus h minus f of x all over x plus h minus x as h approaches 0. Well now, so since the function is a constant and we're looking at the function a little distance of h away from a target value of x, because that's just a horizontal line, the constant is just going to be the same thing. So it's just going to be 5. So it's going to be the same as the original function, 5 minus 5 over h, because the x's are going to, x and negative x cancel, as h approaches 0. Now we subtract 5 minus 5 to get 0. So the limit of 0 over h as h approaches 0 then gives us the limit of 0 as h approaches 0, and that just gives us 0. So the derivative function of f of x equals 5 is just 0. Now move on to function number 3. And the function here is f of x equals x cubed. Again, the derivative function f prime of x is the limit of f of x plus h minus f of x all over x plus h minus x as h approaches 0. And f of x plus h is actually x plus h cubed minus x cubed, the f of x. Now the x and negative x cancel out again, so that's over h as h approaches 0. When we expand out the x plus h cubed, we get x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all over h as h approaches 0. Now we need to cancel out whatever we can here, because eventually what we want to do is we want to make sure that every term that remains has an h in it, so we can do some simplification with the h in the denominator, because as h approaches 0, we don't want to have a 0 in the denominator. So we got x cubed here, we got negative x cubed, so those two can cancel each other out. So we're left with now the limit of 3x squared h plus 3xh squared plus h cubed all over h as h approaches 0. So we notice now that we have an h in every term, which is great. So we can factor an h out, and we're left with 3x squared plus 3xh plus h squared all over h. So now the h's will cancel here. Sorry, that says h approaches 0. And so now the limit of 3x squared plus 3xh plus h squared as h approaches 0 is going to be the next step. And now we apply the limit as h approaches 0, so we substitute 0 in for h, and now we're left with 3x squared. So the derivative function of the function f of x equals x cubed is 3x squared. So now we move on to function number 4, and that function is x to the power 4. Here's the limit definition of a derivative, and then we'll substitute in dx plus h into the function all over all over h. Now we'll expand this x plus h to the power 4. You can do it the long way, or you can remember the binomial expansion. And so when we expand this out, we get x to the power 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h cubed minus x to the power 4 all over h. We'll do some simplifying. So x to the power 4 and negative x to the power 4, those cancel out. We see that each other term here has an h in it, which helps us out a lot when we simplify further. And we'll factor out an h to get 4x cubed plus 6x squared h plus 4x h squared plus h squared. Sorry, you know what? I made a mistake. This should be h to the power 4, and this should be now h to the power 3. And that's over h. The h's will cancel here. So we're left with now the limit of 4x cubed plus 6x squared h plus 4x h squared plus h cubed as h approaches 0. And when you substitute 0 in for all the h's, we see that f prime of x is going to equal 4x cubed. And now for part B of the question, if f of x equals x to the power n, so we're now to use the pattern that we saw in the previous 4 functions to then come up with a little bit of a shortcut, then f prime of x, and notice that when the function is x to the power 4, the derivative function is 4x cubed. When the function was x cubed, the function was 3x squared. When the function was x, the derivative was 1, and when it was a constant, the derivative is 0. Basically here we could actually say this is 5 x to the power 0 if we really wanted to, because x to the power 0 is just 1. Okay, so we could look at that in that way if we wish. And so now the general rule then, called the power rule, is n x to the power n minus 1. So to find the derivative function, we would bring this n, the exponent, down in front, and then subtract 1 from the exponent.